Okay, now you can see it. At the end of class, we wrote down these things over here. So it's your A, B, C, and D values.
Yeah.
Sorry. Thank you. Your A, B, C, and D values for sine and cos graphs. So if you missed that part, you might want to jot it down while it's up there. It's just on the left-hand side of the screen. We discussed that your A value represents something called your amplitude, which is the distance from the middle of your graph to the top of the graph. But that's also the distance from the middle of the graph to the bottom of the graph, right? So it's the same distance both ways. The B value was not your period, right? The B value helps you calculate your period. So they were related to each other. There's these little formulas right here in blue that would help you. I don't think, I've been getting those two formula sheets mixed up so much. I keep forgetting what's on what formula sheet. It's like, yeah, they are different. Like just enough to mess with you. That's not on your formula sheet. So if you're hoping to utilize this formula, you have to have it, this one here, that's disappeared. You need that formula. So why is it not there? It's on my screen. Wait, it's gone. Okay, your B value. I'll write it back out for you. It was 2 pi divided by your period. Which we discussed, that your period is how long it takes to cycle. Your standard mother function, it was 2 pi. You could rearrange that formula so that the period equals 2 pi divided by b. That will not be provided to you. I do think it's probably one you're going to want to know, though. Your C value, oh, I can see what happened. Things got moved around somehow. Your C value is what we call our phase shift. Remember, it's doing our horizontal translation, right? But for this, we just call it phase shift. Just terminology thing. And your D line, we call like your midline or your average. If you don't see it there, I just want to call it your average very often. It's almost always called your midline. Perfect. Let's answer these questions. It says state the range, the amplitude, the period, the phase shift of the functions below. I'm going to do range last, so let's start with amplitude. The amplitude for that first equation is 2. It's the A value. A stands for amplitude. Phase shift. The phase shift is the C value. In this case, it's 45. I know they put degrees. You put degrees, wouldn't be wrong, but we just call it 45. The period. The period of a function equals 2 pi divided by b. In this case, b is 1. So the period is 2 pi. Yep.
You said B is like, it's like the K value, right? In comparison, like when you're comparing the equations?
No, K is the one that gets added on at the end. That's the B value. The K value is...
I mixed up B and D.
Okay. That'd be why. Like D is K, yeah. D and K are related. Alright, the range. To get the range, you need to know the max and the min of your graph. What's the highest it goes? What's the lowest it goes? Agreed? That's what range is asking? Highest the graph goes, lowest the graph goes. You could throw that in your calculator. You could calculate it. You could find it. You could do second trace max. That would work here because there's values, and you could actually graph that. But there's a much, much, much easier way to find your maximum and your minimum. To find your maximum and your minimum, go to your midline, which is your D value, and add the amplitude to it, the A value. That'll tell you where the maximum of your graph is. Midline plus the distance, which is the amplitude, gets me to my max. So for this question, it would be 5. 3 plus 2. The min value is your midline. Subtract your distance to the bottom, your amplitude. In this case, it would be 1. So your range is 1 to 5. Remember, I'm using square brackets because it actually could equal 1 and it actually could equal 5. Cool. Question B is the exact same. You can feel free to try it on your own if you want. We're just going to keep on rolling. It's literally the same thing. Number 3. Which of the following functions has a vertical stretch by a factor of 3 and a period of pi? So, I ran into that problem. Let's start with vertical stretch by a factor of 3. Let's figure out which ones have that. Vertical stretch means your A value. Factor of 3 means it is 3, right? Vertical stretches, it just is what it says it is. That means it's one of these two. Can't be these two. And a period of pi. Period equals 2 pi over b. If I want a period of pi, that means I want pi to equal 2 pi over b. Multiply b to the other side. Divide pi to the other side. And we have b equals 2. That means it's not b and it's not d. It has to be one of these two. Our answer is C. Yes, sir.
And just to be clear, so if we were applying the like transformations of that onto the graph, you would treat the horizontal stretch as like 1 over 2 when you actually apply it.
Yes.
But in the formulas, you usually just keep it as 2.
Yes. Okay. So the b value is 2. The transformation was a horizontal stretch by a factor of 1/2. Okay. So it's only when we discuss it like in a sentence when it gets that flipped around, right? Or if you're trying to do, remember when we take a point and we'd multiply it by something to see where it went? That's when I'd actually multiply it by 1 over 2. But when it's in the formula, we put 2. Yes, sir.
If the question was to ask, like, what's the value of b, would you give it, like, when it's in the formula, or how it actually applies to different?
How it is in the formula. So the actual b value is 2.
Okay.
Yeah. That's tricky, right? Like that's like a common thing that just gets like mixed up and twisted because it's a little weird. Yeah.
So it's the when it's like the C value where it's negative and the it's like actually a value.
Yeah.
Does the negative?
So like looking at this. This has a C value of pi over 3. Positive pi over 3. Right? Like the negative comes from just like our standard formatting.
And if it's like a numeric response question and it's a negative answer, there's no way we're going to have to be able to put the negative.
No. That's usually a good giveaway. Or if the answer is more than 4 digits. Usually a good giveaway that it's wrong, right? If it doesn't fit. Alright, number 4. If the function f of theta equals a cos b theta plus c plus d has a range of -1 to 5, then a or d equal what combination? Okay. Range. Range is telling you high and low. This is a minimum equal to 1, negative 1. This is a maximum equal to 5. Agreed? Cool. Logically, you could try to figure this out. If you're comfortable with understanding how you got to maxes and mins, you went from D and you added or subtracted your A value, and you can just visualize that and figure it out, feel free. That is a legitimate strategy. If you're a formula type of person, there is a formula for your D value. Again, it's not provided on your formula sheet, but your D value is an average between your min and max. So if you add your min plus your max and you divide it by 2, it'll actually tell you your D value. So for this question, my D value would be negative 1 plus 5 divided by 2. My D value is going to be 2. Means it's not A or D. There's also a formula for your A value. The formula for your A value, not provided to you, is max minus your min divided by 2. So for this one, we're talking 5 minus negative 1 divided by 2. 5 minus negative 1 is 6. 6 divided by 2 is 3. I have an A value of 3 and a D value of 2. The answer is C. Logically speaking, D is the midline. It's the middle of your graph. A is the distance to the max, distance to the min. So if you think about it, your answer should make sense. The middle of my graph is 2. Plus 3 should get me to my max. 2 plus 3 is 5. That's the max. To get to my minimum, middle, D, subtract the amplitude, minus 3. 2 minus 3 is negative 1. Minimum is negative 1. It did work. Those formulas are not there, right? Like, they're not on your formula sheet, so you just have to know them. If you're a formula person, you want to memorize formulas, you could definitely memorize those two formulas. Okay. Number 5. The phase shift of a function f of x equals 2 sine 4 theta minus pi over 2 minus 7. Correct to the nearest hundredth of a radian is. Phase shift. Phase shift is C value. The phase shift is not pi over 2. Why is it not pi over 2, even though that so badly looks like the C value?
Because there's no x's.
It's because of this 4. Remember, you can't have a number on that variable. You have to do a greatest common factor. And you need to divide that 4 out front. Then you can see the true C value. So I have to divide that 4 in front. So it now looks like this. 2 sine bracket 4 bracket pi minus pi over 8 minus 7. On your formula sheet, when you look at your formula sheet, bottom right hand corner, it gives you this formula. And it helps remind you that b has to be factored out. Like, that's how it looks on your formula sheet. And it's trying to remind you, you have to take that greatest common factor out to get that c value. I would say, I bet you like half the problem is equal pi over 2. Legitimately. Right? It's just such an easy thing to oversee. And you just like look at it, you're like, yes, c value, got it. And you just answer it really quickly. Make sure you're factoring out b values to find the true c value. The phase shift is pi over 8. It said nearest hundredth of a radian. You could calculate that if you want. It's going to be like 0.36. No, it's going to be higher than that. What was it?
3.9.
Oh, I was close. That's pretty good. Feeling good? That factoring of the b value, we do that for all of our transformation questions. All of them. Okay, 6. Given that f theta equals cos n theta has the same period as the graph g of theta equals tan 2 theta, the value of n is. Okay. This guy. We got to figure out what the period of that is. Now, for this question, we can't use our formula period equals 2 pi over b. That doesn't work. That formula is for sine and cos graphs. Is not for tangent. The reason it doesn't work for tangent is because if you think back to the mother function, tangent has a different starting period than sine and cosine. Sine has an original period of 2 pi. Cos has an original period of 2 pi. Tangent does not. Yeah.
Oh no, I was tracing it out.
It's all good. Tangent has an original period of 1 pi. That means for tangent, we use period equals pi over b. You also, to find a period, could graph it and try to find the period, right? Try to figure out how long it takes to repeat. That's possible. It's just faster if you know how to use the formula instead. So for this question, the period equals 2 pi. Sorry, look, I just made the same mistake I said I wouldn't make. Pi over 2. That's this period, this equation. My goal was to figure out what value of n would give me the same period. To calculate the cosine period, that would be 2 pi divided by n. I want that to be the same or equal to the other period of pi over 2. Do we see how I got that set up? Yeah. The green period would have been 2 pi divided by the n value. So that's the formula for period for cosine. And I want that to be the same as the period for the purple one, which is pi over 2. I now have to solve for n. So I'm going to multiply n to the other side. I'm also going to move the pi over 2 to the other side. You can do that in chunks, right? So I could divide by pi to both sides. And I could multiply by 2 to the other side. And you should end up with 4 equals n. The pi's end up canceling out. We get 2 times 2 equals 4. N is 4. Are we okay with the speed of that algebra? Do you want to see that go slower? I'm just like doing a lot of cross multiplying and dividing. I can smell that Red Bull from here. Can anybody else? That's just a very strong, distinctive smell.
You might be losing your hearing, but you can still smell red.
That's weird. That's weird that I can smell. I'm half deaf, but I can smell from across the room. Basically, like my dog. Like what? All right, number 7. Given the function f theta equals a sine b theta has exactly 5 zeros. For 0 less than equal to theta, less than equal to 2 pi, it is possible to determine that a equals 5, a equals 10, b equals 2, b equals 2.5. Okay, this is a tricky one. What does this mean? Who wants it? Rock, paper, scissors, shoot. Alex.
5x intercepts?
Yeah, that means 5x intercepts. No more, no less. You do it too. I saw the hand go up. Cool. If I want to get 5x intercepts, it probably helped to remember how many I started with. So if you think of your mother function, and think of how that thing looks. It's a sine graph. Sine graph looks something like that. It starts right there at 0. It does one cycle. The cycle completes at 2 pi. Yep.
Go on infinite.
It does. So that's why that arrow is like pointing off. Like it does technically like just keep making this pattern over and over again. It's like getting coterminal, right? It's like being on your unit circle. It just keeps spinning forever.
So how do we get exactly 5 intercepts then?
That's a great question. That's why this is here.
Between 2 points.
Yeah. So this thing in blue is saying, I want 5 intercepts between 0 to 2 pi. I started with 2. Nope, I lied. I started with 3 x intercepts in between 0 and 2 pi. If I wanted more x intercepts in between 0 and 2 pi, then I need to do a horizontal stretch. I need to take this thing and I need to stretch it inwards and compress it. Do we agree with that? To go from 3 to 5, we need a horizontal stretch. An A value wouldn't help you. A is a vertical stretch, right? So we would do this. That's not going to give you more x-intercepts. That's just going to make it like longer. A C value wouldn't work. A C value is just moving this thing to the left, right? So that won't get me more or less x-intercepts. A D value moves this thing up or down. That's not really going to give me more or less x-intercepts in here. Perfect. Look at the answers. That means there's only two answers to look at. C or D. What I would do is I would test both those and graph them and see how many x-intercepts that you end up getting when you have a b-value of 2 or a b-value of 2.5. Considering we haven't graphed a trig function at all, it's probably a good thing to practice right now. So you want to take out your calculator. We can try graphing this. You go to your y equals. You're going to try sine of 2x. Your window. Your x minimum is 0. Your x maximum is 2 pi. Your y minimum is -1. Your y maximum is +1, right? That's the lowest my graph goes, highest my graph goes.
Oh yeah. It's revenge. I've been harassed a bit.
I believe it.
Yeah.
Your mode has to be in radian mode. If it's in degree mode, it's probably not going to work. You hit graph, and you get that. That b value of 2 gives you 1, 2, 3, 4, 5 x-intercepts. It is important.
To Mr. Paul's room. Grace to your father's room.
That'll be fun, I know. It is important to note that it said that we could equal 0 and we could equal 2 pi. Otherwise, if it didn't say equals, those first and last x-intercepts wouldn't have counted. Right? So it did say less than or equal to 0. So those first and last x-intercepts do count. I need a b value of 2. If you tried 2.5, you can't see my calculator. If I try 2.5, that would give you 1, 2, 3, 4, 5, 6 x-intercepts. Yep.
Can you just tell me one more time how I tell where
Oh, here.
On that thing? Looking at the x values, like you really can't. Not the way I have it set up right now. I think that's fair to say.
Oh, your window is too. I can too big.
Boys, just quieter. I know you're helping each other, just too loud. Just quieter. Yeah, it's good you're helping each other, just you're being really loud. Go to your window, go to your x scale, and put pi there. And then you know every tick is 1 pi. And that'll help you figure out where 2 pi is. Alright, so here's 1 tick, that's pi. My second tick is right there. It's a little hard to see, but it is there. So that would tell me 1 pi, 2 pi. And then I can actually tell. If I don't change my scale and I leave my scale at 1, which is honestly what I usually do, then you actually don't know where you're at. So if you want to be able to look and see by ticks, change your scale.
Also, on the diploma, if my pi symbols look like M's, are they going to drop me marks?
You'll be alright, they'll figure it out.
Because my pi symbols look like M's.
If I start marking a diploma and I see pi symbols that look like M's, I'll give it 100%.
Thank you.
That's recorded. Going to prison. I'm not marking a diploma, don't worry about it.
You're trying to defend yourself on your own.
I know, I'm trying to. I was just joking. I might mark your diploma though. Just right along. Also joking. Okay, number 8. Now that I've, what's that? Is that incriminating yourself? Yeah, now that I've self-incriminated. Okay.
Can't plead the fifth.
Can't plead the fifth once you've already done it. Yeah, you're already in. You're already in. Anyway, the domain of the function y equals tan 2x is. Okay. Domain. That's possible x values, right? The x values get really wonky for a tangent graph because of all the asymptotes. So if you think about it, let's go back up to our tangent mother function. If I wanted to talk about the regular domain of that thing, that thing has a domain, that's an R. Wow, okay. My hand's not doing what my brain's telling it to do. Do you think I can make a D? Why was that so difficult?
It's Friday.
That was...
Friday the 13th.
Is it the 13th? That was actually hard. Why can't I make a D right now? Yeah, that's a good point. The domain for just a regular function would be x as an element of the reals because it goes left and right forever. However, x cannot equal any of those asymptotes. You'll notice those asymptotes happen at pi over 2 and then every pi after that. So plus pi times n. Asymptote happens at pi over 2 and then every pi afterwards. Positive or negative, right? This is a pi away. This is a pi away. Are we okay with the mother function domain? I'd like to move it over a little bit so I can finish it. Where n is an element of the integers. Remember that n has to be like a whole number. Yeah? Can't be a decimal. Before we get to the harder one, I just want to be like, are we good with this domain? Oh, I'm jealous. I'll remember this. That's on recording too. Like, Mr. Carey's not nice. See you later, Mr. Pierce. Alright, the domain of this function. It's going to be slightly different. And it's slightly different because of this stretch. It's horizontally stretched it. It's actually made it come in a bit. If I wanted to get the domain of that, I would graph it. So I go to my graphing calculator. I would graph tan of 2 pi, or sorry, 2x. I'd go to my window. My scale is going to be important here, because I want to be able to count how many ticks I'm at. Probably the best thing you could do is pi over 4. Pi over 4 tends to work out really nicely because 1 pi over 4, like that's easy, but then 2 pi over 4 actually tells me pi over 2. And then I have 3 pi over 4, and then I have 1 pi. So it tells me actually a lot of important points. So a lot of the time, if I really need to graph my scale, I'll do pi over 4. Because then I can see lots of different points that I'm interested in. Hit graph. I get that thing. My asymptotes are right here, here, here. And you can tell the pattern is happening 1 pi over 4, and then you get it 3 pi over 4, then you get it 5 pi over 4, and then you get it 7 pi over 4. Right? There is little ticks in there. That would have been 2 pi over 4, that would have been 3 pi over 4, that would have been 4 pi over 4. So my domain will be x cannot equal pi over 4. That's where my first asymptote was at. Plus every half pi times n. Here's my first asymptote, pi over 4. To get to my second asymptote, that was 3 pi over 4. That's a half a pi away. That's 2 pi over 4 is away. 2 over 4 is 1 over 2. So it's pi over 2 away. Again, I multiply it by n because it happens every half pi, and n has to be an element of the integers. Answer is, oh gosh, no, it's D. You guys have practice tonight?
No, I just don't know.
Oh, you just want to ditch me. It's okay. I'll just publicly call you out and shame you and name you on this video. Goodbye, Calvin.
What?
No, I don't think I'm helping you for the video, Devin. Now you've been ratted out. Now they know it was you. I tried to help you. He was so offended. He actually thinks I thought he was Calvin. You did take that to heart. I'm sorry. Sorry for helping you. What's up with that?
Why wouldn't we be able to just multiply the d value to the bar?
You would. You'll notice it's actually the exact same thing. So if you remember horizontal stretches, so if you didn't want to graph that and you're like, oh God, I don't know how to graph it. Horizontal stretches affect your domain directly, right? So this horizontal stretch multiplied by 1/2. And you'll notice that the mother function domain has just been multiplied by 1/2. That would depend on you remembering the mother function domain, which maybe you do remember. Now I feel bad. I feel like Devin thinks I don't know who he is. I call, oh, okay, I was going to say, I call Kaylin and James the wrong names all the time. I don't know why. And then I don't know you guys are twins. That's more embarrassing. That's fair. That's far worse. Yeah. But I knew you both had a sister named Jordan. Does that count?
That almost makes it worse.
It makes it way worse. Like, way, way worse. That just means I'm stupid. Kids at number 9.
Everyone just is.
No, they're not going to let me mark diplomas at all. Like, this guy can't even know twins in his class? Number 9. We're going to have to make this video not public. The partial graph of the cosine function below has a minimum point at pi over 2, comma, -2, and a maximum point at pi, comma, 8. The equation of the function can be expressed in the form, blah, 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 cosine. The values of A, B, and D are. Alright, B is definitely the hardest. You have a graph, finding B, not fun. A and D from a graph should be pretty easy. Start with D. Is that a question for me? Oh, okay. D is the midline, right? So look at your graph and see if you can sketch a midline. If you're not sure how to sketch a midline, figure out where the highest one is, figure out what the lowest one is, add them together and divide by 2. And that'll tell you where your midline is. For me, I'm more, what could we say, elementary, not stupid. Right? I just would count. So like, down 1, up 1. And then down 1, up 1. Down 1, up 1. Down 1, up 1. Down 1, up 1. My midline's right there. Legit, that's how I would do it. Right, my midline's at 3. And then through paranoia, I would then make sure my midline's right by making sure that's the same distance to the top as it is to the bottom. So if you look, like these distances should all be equal. If they're not equal, then you don't have the right midline. If they are equal, you got the right midline. All those purple lines I just drew are all the same distance. Distance of 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My midline is in the right spot. These distances are all 5.
Sorry.
Fire.
Work thing.
Work life. I get it. I did that once.
We'll see after the video.
Yeah. I told you guys that I got a different job. I actually got fired back in November, and I just kept showing up. No. I just come to this class. They never hired anybody else. I just volunteer now.
doesn't actually work.
Yeah. That red line I drew, that midline, that's your D value. That distance to the top and the bottom is actually your A value. Right? That's your amplitude, distance from middle to top. That's your A value. So I know A is 5, D is 3. What I don't know is B. B is always going to be the trickier one. C is the hardest one. We don't have a C value, luckily. But B is definitely a little bit trickier. B equals 2 pi divided by the period. Figure out the period. Probably the best thing you can do for period is figure out where the y-intercept is. Right here. And then figure out when that moment repeats itself. So I go down, I go up, and then I hit that same level up there. My period is this distance. I swear my writing's not that bad. It's just my Chromebook connecting. My writing is bad. It's not that bad. That says period. The reason I like using the y-axis is because then I'm counting from 0 to something. That's easier. All right. So 0 to pi is a distance of pi. That means my period is 2 pi, or sorry, my B value is 2 pi divided by pi. My B value is 2. Values of A, B, and D are 5, 2, and 3. Yeah, number 10. Determine an equation in the form. I got cos and I got sine. Sorry, I got NBA 2K updates coming in. I got determine the equation in the form of cos and sine. Remember I said like cos and sine are the same thing. They're the same graph, but just shifted over. Right? They're the exact same pattern though. So when you get a graph, you technically could write it as a sine equation or as a cos equation. You could do either one. This question, I'm going to start with sine. Let's make our sine equation first. It'll be a little bit easier. Cos will be a little bit harder. All right. Starting with sine. Always easiest to start with your D value. The D value is your midline. Right, looking at this, sketch your midline. If you sketch it wrong, so say you sketch it like, here. Like it's wrong because the distances aren't the same. Like that distance to the bottom and that distance to the top are not equal. So if you accidentally put the wrong midline, like it should be obvious. I got that wrong, right? 0.5, that's 1, 2, 2.5, 1, 2. Yeah, it's way wrong. Try again. Trying to draw a midline. Let's try here at 1. That looks a little bit closer. To know if you're correct or not, check to see if the distance to the top and the distance to the bottom are the same. I don't know how much more my computer's going to last. It's really struggling. This distance, right? In terms of blocks, not actual units, because these units are 0.5s. I'm 1, 2, 3, 4, 5, 6 blocks. This one is 1, 2, 3, 4, 5, 6 blocks. Got it right. My D value is 1. Perfect. My amplitude is the distance from the middle to the top or distance to the middle to the bottom, because it's the same distance. My A value is not 6 here. Just be aware of the scale, right? Like this scale is going up by 0.5s. This is 0.5, 1, 1.5, 2, 2.5, 3. It's a distance of 3. It's the same distance of 3 to the bottom. 0.5, 1, 1.5, 2, 2.5, 3. Distance of 3. Perfect. Let's do B value next. Your B value is 2 pi divided by period, because we're talking about a sine function. Again, if you can start at the y-axis, it's probably the best place to start, because then your counting's easier. So I'm starting here. I'm going to go along my graph till I've completed one cycle. So it goes down, up to the top, and then back down to that midline right there. Those points are at the same level, and they're making the same pattern. That's one cycle. That one cycle took pi. Right? This distance right here is 0 to pi. My B value is 2 pi divided by pi. It's 2. For the record, A, B, and D are the same for cosine. They're the exact same. The only thing that's different is your C value. It's how this thing has been shifted. Perfect. To figure out how it's been shifted, you have to remember what your mother function looked like. So your mother function for a sine graph starts like this. Right at the midline, and then it goes up. The only way that point would move is by phase shifts and vertical translations. It won't be affected by stretches. A horizontal stretch, not moving. Vertical stretch, not moving. So what you need to do is look at your graph, try to find where that point has gone to. It is right here. It's crossing the midline and going up. The original graph, this would have been at the origin. It would have gone up, down, up. But it was transformed over and up.
So how would you know that it's that point there and not like the one underneath the I period?
Yeah. It could also be this one, and you would not be incorrect. So it could actually be either. You could have shifted it left or right the same distance, and you still would get a sine graph. And then technically, there's even more. There's more B values. Like if you think about that graph's infinite, right? So there could be another one like out here somewhere.
Would the diploma take any preference to which one?
Sometimes yes, sometimes no. When reading the question, be very aware if they say your C value is positive or negative, because then it would make a difference. If they say that you did a phase shift that is positive, right? That means I must have shifted to the right. If I said that my C value was negative, it means it shifted to the left. This question doesn't specify, so both would be correct. And they would know, like, when you go to mark them, they would show us probably like 5 or 6 different phase shifts that we would have to accept as correct phase shifts, in case somebody went like way off the chart for some reason. Yeah, so.
Just to clarify, if they're telling you like you have a negative C value, they're not saying that in the equation that C value is negative. It's saying like the actual value.
The actual C value would be negative, yeah.
So in the equation it would be positive.
Yeah.
Okay.
Figuring out that C value, that's the distance that that point has moved over from the y-axis. It's that distance right there. That is 0.5 pi. I'm talking about going left, so it would be negative 0.5 pi. You also could say it went to the right. You'll notice it's the exact same distance, but it would be positive 0.5 pi. That's not always the case where it's the same value, but it's nice if it is. That means my equation I'm going to put will be 3 sine 2 bracket theta. Let's do minus 0.5 pi bracket plus 1. The beauty of a graph and having to make the equation is you could always graph it to see if you got it right. Like, it's an easy thing to verify. Put this in your calculator, create the exact same windows I gave you. X minimum, negative pi. X maximum, positive pi. Scale, pi over 4s. Y maximum, 4, minimum, negative 2. And you should see the exact same picture. If you don't, you made an error, right? Okay, before I move on to cos, does anyone see a different sinusoidal equation I could have made? Because there is one other sinusoidal equation you could have made. I'd be shocked if anybody did make it, but in future transformation questions, you might need to do that.
Wait, another way to make it to the way it's supposed to be?
Another equation that would create the same graph.
Couldn't you, can you make it like add like, what is it, 1 pi?
Without changing, not doing a new C value.
Oh.
Is there another way I could get that same graph?
Yeah, using cos and then doing a different phase shift.
No, still sine.
Still sine, okay.
It's a tricky one. I could vertically reflect that graph. And so if I did a reflection of this graph, it would have just flipped upside down. And then actually my starting point would be in the right spot already. Because then I would go from here up. And I wouldn't even require a C value anymore. So you also could have said that was a negative 3 as my A value. That's a lot trickier. I don't think you would ever be required to do that. But we did have some transformation questions where it was like, what's another transformation that gets you the same graph? You might remember that. And those were usually simpler questions, not quite sinusoidals. Sinusoidals are a lot trickier. But technically, I could do something like this. Negative 3 sine, it's still 2 theta, and then plus 1. And there's no phase shift at all now, because it's been reflected. That'd be a really cool answer to put down. Same amount of marks, though. Even if it's more clever. Do you see that? Like how it flips like that? The D value would still be the same. The period would still be the same. The A value would still be the same. It's just reflected. Now I'm wondering if that actually works, because I feel like for some reason it's wrong. Did anybody graph it? It worked, right? Now you're all freaking me out. I just see some like looks in me like I'm crazy, which usually when you guys all are giving me that look, you're right. Negative 3 sine 2x plus 1, right? The window went from negative pi to positive pi. The scale was pi over 4. The minimum was negative 3, right? Maximum was like 6 or something like that. Oh yeah, see, it worked. Doesn't feel like it should work, eh?
No,
No, it like, I don't know. It does work. Did I confuse you with that?
Wait, but how does that fix the issue? Because doesn't it have to start, because it's a sine graph, doesn't it have to start on the top of the y-axis?
It has to start at the midline, going up.
Yeah.
So if you flip that, this point would still be on the midline, but then it would go up. It would go like this.
Yeah. Okay.
Which means it's the starting point now was never moved.
Okay.
Yeah. You don't need to know. I maybe shouldn't have even said anything. It's just good. It was just a good thing, like, because when it comes to transformations, that is something that happens in transformations. What's another transformation that gives you the same thing? Like, that does happen, right? Just usually with only one point, a lot more basic. Okay, let's try creating our coast graph, and then I'll be done. A, B, and D are all the same. Okay, so don't worry about A, B, or D. The only one that's going to be different here is C. To know that, you have to remember where you started on a coast graph. Your mother function for a coast graph starts at the top and goes down, like this. Starts at the top and it goes down. So I need to look for a maximum point that goes down from that. Looking at this thing, there's my maximum point that goes down. I need to move that thing back over to the y-axis. That distance is my C value. It's a harder one to know because it's not labeled nicely for measuring. It's the same as this distance. To figure out that distance, figure out what their scale is, figure out their scale, I would go like 0.5 pi divided by 2. This is halfway between 0.5 pi. This is pi over 4, or 0.25 pi. Pi over 4. Another technical C value you could put is this point over here. Right? It's a maximum and it goes down. So instead of saying I went to the left pi over 4, you could say or it went to the right 1, 2, 3 pi over 4. So I either went to the left, so negative pi over 4, or I went to the right, 3 pi over 4. Both of those would be correct, because you're just shifting the whole thing over. Let's go with our answer is y equals 3 cos square bracket. B value is still the same, it's 2. Theta, let's go plus pi over 4. Right, because I went to the left, so it was minus. 2 negatives make a positive. And then plus my D value of 1. That's a pretty tricky, hard skill, but it is something that comes up quite often. Okay, I've sufficiently embarrassed myself.